Hi everyone, my name is Adam Azam and I'm a Principal PM here at Prefect. Today, I'm really excited to introduce ControlFlow. ControlFlow is a Python framework for orchestrating agentic workflows built by and on Prefect. Agentic workflows take advantage of a large language model's innate ability to reason about a problem and create a workflow iteratively and dynamically on the fly. Agentic workflows dramatically expand the surface area of what software can build, but unfortunately at the expense of where things can go wrong. At Prefect, we've always treated failure as a first-class citizen of designing workflows, and we're bringing that same experience and vision to tackling agentic workflows. Before we dive in, it's important to reflect on how we got here and what we've learned in the past year and a half working with dozens of teams to productionalize AI workflows. If you don't have a background in machine learning, no worries. For the purpose of this talk, we can go with the most reductionist understanding of large language models. Large language models, like ChatGPT, are basically omniscient autocomplete with a really bad attention span. They're trained to see a sequence of tokens or words and simply predict the next token, and they do this iteratively until they can stop. And so in this sense, they're really just auto-completing the sentence that you start with. This turns out, through research, to show incredible performance on classical machine learning tasks, like classification. If you simply put in the text of an email and you ask it to autocomplete, is this email spam or not spam, it's incredibly robust without any additional data at correctly classifying whether or not something is spam or not. So you can take something that's classically autocomplete and turn it into a classification tool. Similarly, it's incredibly robust at extraction tasks. This same email, somebody's inviting you to a party, somebody's inviting you to an event, you can simply ask a large language model, here's the text of an email, can you generate any events or any guests that you see in this email? And it's incredibly robust at extracting these entities. And the last piece is around choice. So we've seen, and what's inspired the imagination of thousands of developers is the ability of large language models, when given a suite of tools to choose from and some context about its mission, it's able to correctly choose a tool, format its input, and execute that tool on your behalf. And so really, you can take this tool that was designed for autocomplete and you're able to repurpose it in a lot of different ways simply by prompting it correctly. That same model, you can ask whether or not an email is spam or not spam. You can ask it to extract all the invites and all the guests in an email. Or you can ask it with the same base information, am I actually free during any of these times? Go check my calendar. And so we found that large language models are incredibly robust at classification, extraction, and reasoning. And so it's no surprise that about a year and a half ago, as folks started seeing some of the research that was coming out around large language models' innate ability to perform these tasks with no additional data, that folks really attempted to stitch these things together in order to create really durable pipelines to tackle advanced tasks. We had the great fortune to work with some of these early teams, put these into production, and we saw very early on that large language models were not particularly good at complex reasoning. So we saw teams try and do this all the time, where, if they were trying to take an incoming email, figure out if it was spam, extract the events, and see whether or not they were free during that time, they would try and dump all of this logic into one single prompt and try and get some sort of nice output out of it. And what we saw consistently was that large language models were incredibly bad at complex reasoning. They either had insufficient context or their decision space was far too large. And we found that the tool sets that they had were incredibly flaky. Whether it was the inability to actually access a Gmail API because of ill-formatted input, or it was just the choice not to use that tool at all despite clear instructions. And so that large decision space and that poor context really made this initial style of working with LLMs insufficient to bringing them into a classical software stack. The workflows that folks built were inscrutable, they weren't particularly testable, and they were flaky because we were asking LLMs to do too much all at the same time. And so over the last year and a half, one of the things that we've learned most about building resilient AI workflows is to make small tasks and to encapsulate the logic in small bite-sized pieces of work that LLMs can do. And so for these classical tasks like classification, extraction, and reasoning, what we've helped tons of teams build are saner pipelines. So your today's LLM pipeline resembles a lot more like how you would write classical software. If I'm trying to figure out what to do with an email, I first might try and figure out whether or not it's spam. I can pass that off either to an LLM to detect whether it's spam, or I can pass it off to something that's more like a classical ML pipeline. For every invitation that I see and can detect from that email string, now I'm going to take an action against it. I'm going to check my availability, and I'm going to start to author a response to it. And so this really has two pieces to it. So why is it that we have coalesced as a community around these styles of workflows? It's really because they can be decomposed to two parts. You have the non-agentic workflow part of this. This is, as you can see, all of the human logic that we're writing into this. We first tell an LLM, your first mission is to detect whether or not this thing is spam. After you've completed this very atomic task, I'm going to tell you what to do next. I'm going to ask you to check every single invite that you can detect in the string. And only for those things that you've successfully extracted, now I'm going to tell you to take a discrete action for every time that I'm available during that event. So really, this is an appealing way of authoring LLM workflows because we've taken all of the decision making out of an LLM's hands and we've exclusively put it in our own. So this has become a really robust framework for building workflows because really it looks a lot like the last generation of software that we wrote. The way that LLMs are used in this paradigm is they're used for essentially calling out as if they were classical ML models. And this paradigm of building LLM workflows benefits from being inspectable, from being testable, and controllable. Each one of these things is a small gear that you can inspect, that you can measure its performance over time. You can build rigorous evaluations around, and you can detect its drift over time as well. The other half of this are LLM evaluated tasks. About a decade ago, if you were getting your start in ML, you wouldn't have been able to call out to a large language model to tackle all of these tasks. You would have used a much more basic classification task like a random forest or naive Bayes at the time. You'd have had to collect thousands and thousands of training samples and then rigorously annotate them so that you can build robust models. And of course, the appeal of large language models is that they're incredibly good at zero-shot tasks. You don't have to pass in a lot of data. You don't have to show them a lot of examples. They've been trained on essentially the entire internet, and so they're incredibly robust at figuring these things out for themselves. So they have a very wide surface area of tasks that they can tackle. You don't need to show it a lot of data for it to figure out if an email is spam. You don't need to show it a lot of examples of what invites or guests look like. It can extract that for itself. And you don't have to teach it how to use an API. You can really show it the spec for that API, and it can intuit how to format responses to it. And again, by splitting this up between what a human authors and what an LLM executes, makes it again very inspectable, testable, and controllable. Which is why this paradigm has been incredibly popular. Non-agentic workflows really resemble software 1.0. The workflows that you saw in the previous slides really resemble workflows that you would have written a handful of years ago. They're expressible as a directed acyclic graph. They're easily testable, inspectable, observable, and for those reasons, they're easier to trust. They're easier to trust due in part because they have really no decision space. You're restricting what it's allowed to do, and so to evaluate these things, it's familiar. It comes down to, did the outputs match my expected inputs? And this is easily still the best choice for building early pipelines that pass the intern test. Is this a type of work that you would pass off to an eager intern? Is it an incredibly well-scoped task that you don't need a lot of additional context in order to tackle? But of course, what this really suffers from is, despite having a large surface area of inputs, right? An LLM can contextualize and understand to a fault whatever you put into it. It may not understand it well, but it's able to accept a wider amount of input than your classical machine learning algorithms can. But it has a very small surface area of outputs. Since you've constrained what it's allowed to do, it's not allowed to think all that creatively. It's really just being forced through a very narrow channel to perform exactly the small tasks that you've asked it to do. And for that reason, it's largely constrained by model intelligence. On the flip side of this, we have agentic workflows. Well, agentic workflows are largely when orchestration logic is handed off to a large language model. So whereas in the previous slides, we were rigorously defining, first you want to go and check whether or not this thing is spam. Next, you want to go and extract all the invites from this. Next, you want to go perform this other task. For an agentic workflow, we're really giving it a high level objective, which is respond to this email except if I'm free, and accept the invitation if I'm free. And what distinguishes an agentic workflow from a non-agentic workflow is that an agentic workflow will create, reflect on, iterate on, and execute on its own plan. It uses tools that you provide to it at the start, or it can create its own tools in service of its objective, and it can run it against a sandboxed environment. Now, to do this, is the juice really worth the squeeze here? Are we simply turning over orchestration to an LLM for no real gain? And this was really answered resolutely by a handful of papers. One most notably is from Alpha Codium, where they basically showed that if you take GPT 3.5, right, the most simplistic model, most simplistic and performant model that we have, and we give it the ability to create, reflect, and iterate on its own plan, it can easily dwarf a much smarter model like GPT-4 by being able to reason in a loop instead of just having to do one single shot execution. Oftentimes, this is the only choice for complex tasks with a huge decision space. Most notably, for large coding tasks where one needs to iterate over a large code base, or for research tasks where one has to collate an immense amount of research, be able to whittle it down, refine on its thesis, and be able to distill down its sort of core conclusions. So both of these are incredibly good examples of where agentic workflows really are the only tools that we have available to us. And really, I want to talk about what makes agentic workflows hard. One of the hardest things about agentic workflows is that workflow isn't known at runtime. When you have a pre-registered DAG, directed acyclic graph of function calls, it's really easy to know where things went wrong because there's sort of only one way that your workflow can play out. Your evals are path dependent. And what I mean by that is in a classic deterministic workflow, it's easy to design evaluations. It's easy to say, look, when I put in these inputs, I expect my LLM to give me these deterministic outputs. And so it lets me write things like unit tests with a lot of ease. With dynamic agentic workflows, now success of a workflow can really depend on its internal reasoning and the path that it took from A to B. It's incredibly hard to inspect dynamic workflows. And we know, we've built this for an entire fleet of data engineering pipelines. With agentic pipelines, it can be even tougher because you don't really have a lot of good observability into the internal reasoning that an agent is using to figure out its next step. And these failures compound. Whereas in a deterministic pipeline, at every single step, you can explicitly author how you want to mitigate its poor decisions that it makes. With an agentic workflow, often, since it's dynamically figuring out its own execution plan at runtime, it can be hard to write in safeguards to actually account for that at runtime as well, to sort of mitigate it and grow alongside of it. This is why we're excited to introduce ControlFlow. ControlFlow, built on Prefect 3, really enables us to tackle these four horsemen of building dynamic workflows. We've got incredible observability tools to inspect the internal reasoning loop of agentic workflows. We've got the ability to understand longitudinally how these workflows behave over time to enable us to build evals not just off of inputs and outputs, but over their paths as well. Prefect is purpose-built to not have to pre-register workflows ahead of time. So it's the only orchestrator that we can use to govern agentic pipelines because their execution is not known to us at runtime. So I want to show you a little bit about how this works. In ControlFlow, there's really three core pieces. We have agents, we have tasks, and we have flows. You can tell it was built by Prefect, right? So an agent is the fundamental character who's going to be executing a unit of work. This could be a data analyst, this could be a data scientist, this could be like a brand agent, a travel agent, what have you. Could be somebody that's especially good at coding. And the role that an agent plays is that it enables you to really focus a prompt in to activate certain parts of your network's weights so that I can really start to build an expertise to tackle this task. And so really you can make agents as rich as you want. So not only providing a name, you can provide its description, which can be witnessed by external agents. You can provide instructions, which only it can see. And also you can provide a set of tools for it to be able to use when it chooses to, if it chooses to. After defining an agent, we simply have to define a task, something as simple as analyzing sales data. I can give it access to this agent, so when I go to execute this task can really call out to this specialist in order to execute its work. So instead of having to say declare in your initial prompt, you are a data analyst, here's the task that you're trying to do, instead we invert it. We say that, look, here's the task we're trying to accomplish. You have access to this roster of experts. Those experts have access to their own tools. And so this really lets you surgically define your contexts so that you can correctly tackle these problems. And the last piece is around our flow. So a flow is the central context through which we manage the execution of an agent. Really with a flow, you can dynamically submit tasks to it, or you can simply say, while this task is incomplete, I want this agent to run this task. And so what this really enables you to do is it creates a fundamentally simple developer experience for governing these while loops so that you can really let an agent plan, iterate, and reflect on its own plan. Of course, you don't have to register all of these tasks ahead of time. You can dynamically register tasks to flows as well and give your agents access to these tools. So if your agent in the execution of a flow determines that it doesn't have it creates its own plan and it needs to be able to dispatch those tasks to something, it can dispatch it back to its own flow context and continue this loop as well. And so we have an imperative API for working with flows and tasks, but for Prefect users, rest assured we have your classical functional API for working with tasks and flows as well. Every flow in ControlFlow, it's a flow in Prefect. And every task in ControlFlow is a task in Prefect, which means that as you author agentic workflows in ControlFlow, you automatically gain access to the resiliency and observability that Prefect guarantees. And so tasks as simple as, get a user's name and write a poem for them is easily expressible in our native flow task syntax. Next, I'm going to show you a demo of the observability that you get when you work with a ControlFlow pipeline. Let's dive right in. We're going to make an agentic workflow to do a job search for me in the background. So for the purposes of this example, I'm going to be a full stack developer who's interested in doing a job search, but I don't really have the time to do it. So I'm going to dispatch an agentic workflow to work in the background 24/7 on a schedule to check new jobs for me at Stripe. So the first thing I'm going to do is I'm going to define some agents who are going to play core characters here in my job search. I'm going to have something that represents my interests, my job coach bot, my agent, who's always trying to find the right way of explaining why I'm a particularly good fit, how I can prepare. And then I've got a recruiter who represents the interests of a company. So I'm going to set up these two agents, and these agents are going to really be the ones that are orchestrating the tools that we define in task.py. So in my tasks file, I've got a handful of deterministic functions. These are Prefect tasks. I can read and write files, I can scrape jobs from a job board, and then I can go ahead and send a notification to my personal Slack instance when I found a particularly good fit. Now, then I've got some agentic tasks. I've got a task that's responsible for determining whether or not I'm a good fit for this role, and that task is going to be able to look at a specific job, and it's going to be able to look at a resume. Now here, I've binded a recruiter to determining whether or not this is a good job fit. I could have easily included both the recruiter and my job coach bot if I wanted them to sort of war it out over whether or not I was a particularly good fit. I want something marginally more conservative, so I'm really going to have the representative of the company really be the gatekeeper of whether or not I'm a good fit. Now that I've got my characters, my agents, my tasks defined, it's just a matter of defining the workflow logic. So in my main.py file, I've got my job board subscriptions. Here I'm just interested in Stripe for the moment. So I'll import my tasks, and As I loop through my subscriptions, here it's just Stripe, I'm going to go get all their jobs. Now, I'm going to go and I'm going to compare and determine whether or not any of these things are a particularly good fit using my agents. So since this is a Prefect flow, this is going to give me a live preview link for me to go and inspect this while it's running. And now I've got a live look-in to the actual behavior of my system as it's executing. So let's go and inspect this. I can see that I've read in my resume, I've gone and actually fetched my jobs, and then now what each of these represents is this represents a low-level LLM execution. I can inspect any one of these executions, and I'll see that not only did it complete, obviously, but it left me a markdown message. And this is showing me that, look, this job that it inspected required 10 years of sales experience in Japan, and I'm not a particularly good fit because I'm looking for a full stack role. I've got a new message. So here, it's notified me of a backend API billing at Stripe and why this is an excellent fit. It's explaining, given its tech stack, why this aligns very well with my background. I've worked in cross-functional roles at Amazon and Pfizer in my projects, and that this is going to be really important to cross-functional roles at Stripe. And my specific projects between ShareBuddy and Watchlist are particularly good for what they're looking for API development. I want to talk about what's next for ControlFlow. As we've seen, collecting good data is absolutely important to build good evals for your workflows. And so we're making it easy to do that. But not just easy for defining inputs and expected outputs, but for understanding the full execution plan of your workflows. We're bringing Prefect's native caching and idempotency APIs straight into ControlFlow. And we're making it incredibly easy to schedule those workflows, respond to events, and deploy those on your infrastructure dynamically. Thanks so much for your time and joining us. Really had a blast showing you some of the early pieces around ControlFlow. You can check us out at controlflow.ai, join our community on Slack, pip install ControlFlow, and get started today. Thanks.